Imagine standing next to the sun. You'd expect an incredible roar, right? A sound so powerful it could shatter everything nearby. But strangely, you wouldn't hear a thing. How can the sun, a massive, boiling ball of plasma, produce sounds, and yet we remain completely deaf to them? Today, we're diving into the mysterious sounds of our sun and why, even though it's constantly singing, we can't hear its cosmic symphony. The sun is far from silent. Its surface constantly vibrates, creating waves that ripple through its layers. Scientists call these solar oscillations. They're caused by the turbulent motion of plasma, the superheated gas that makes up the sun. These waves are similar to sound waves here on Earth. On our planet, sound is a vibration traveling through air. On the sun, sound waves travel through plasma. The sun's surface pulses, shrinks, and expands rhythmically, almost like a massive, glowing heartbeat. But unlike a drum or a speaker, the sun's vibrations are far too slow for our ears to detect. Some of these waves have frequencies of just a few millihertz, meaning a single oscillation could take minutes to complete. Our ears, designed for the 20 Hz to 20 kHz range, are completely blind to these slow cosmic rhythms. Let's break this down. Sound requires a medium to travel: air, water, or solid matter. On Earth, our atmosphere carries waves from a voice, a guitar, or a thunderclap directly to our ears. The sun, however, is mostly plasma, extremely hot, ionized gas. Its surface and outer layers are incredibly dense and chaotic, and the waves generated there move much slower and with much lower frequencies than what humans can perceive. If you tried to listen with your ear, you wouldn't hear a thing. Even if the sun's waves reached us, they would be far below the range of human hearing. In fact, to translate the sun's vibrations into something we can understand, scientists have to accelerate the waves millions of times, turning them into audible sound. This is where the fascinating science of helioseismology comes in. Helioseismology is like seismology on Earth, but for the sun. Just as geologists study earthquakes to learn about our planet's interior, scientists study solar vibrations to learn about the sun's inner layers. By observing tiny movements on the sun's surface, some smaller than the width of a human hair, scientists can map the sun's structure, temperature, and even the movement of its plasma. These solar sounds tell us incredible things: how the sun rotates, how energy travels from its core to its surface, and even clues about solar storms that can affect Earth's technology. Without these vibrations, we'd have no window into the sun's hidden interior. So how do scientists let us hear the sun? The key is speed up. By taking the sun's oscillations and increasing their frequency millions of times, we bring them into the human hearing range. When you listen to these recordings, what you hear is a mesmerizing, otherworldly hum. Some describe it as a haunting choir, others as the steady pulse of a cosmic heartbeat. These sounds are not just for curiosity. By analyzing the frequencies and patterns, scientists can predict solar flares and better understand the life cycle of our star. Every note, every hum, is a piece of a puzzle that reveals the sun's secrets. While we cannot hear the sun directly, its music affects Earth in subtle ways. Solar activity influences our planet's magnetic field, auroras, and even satellite communications. Scientists monitor solar vibrations to prepare for geomagnetic storms that could disrupt power grids or GPS systems. The sun's rhythm is also a reminder that our universe is alive with motion and energy beyond our senses. Just because we cannot hear it doesn't mean it's silent. In fact, the sun has been singing for 4.6 billion years, and it will continue long after humans are gone. So next time you look up at the sun, remember, it's alive with vibrations, waves, and sounds, a cosmic symphony playing just out of reach. And thanks to science, we found a way to bring that music into our world, reminding us that the universe is far more dynamic and mysterious than our senses alone can perceive. Subscribe to uncover more hidden secrets of the universe, and let's keep exploring the sounds and stories of the cosmos together.